All right, everybody, good afternoon. Can you believe this is our final talk in 1B today? What an amazing, what an amazing, eventful day it has been. We've had so many talks, from toxic traits in the workplace to AI of the future, penetration testing, and to finish us off today, we have Mick O'Doherty talking about streaming video technology. So, video streaming remains a frustratingly complicated domain for developers and content owners alike. Multiple formats, streaming technologies, security technologies, etc., all conspire to make successful streaming an art as much as a science, even for the big providers. Streaming video, why it is so complicated and why it is going to get even more complicated, will be explained by Mick O'Doherty. Thank you.
Thanks, Gemma. Is this on? Can you hear me? Okay, perfect. You can hear me fine, yeah. Okay, thank you, Gemma. So I'm going to try and move out of the light so I'm not blinded. I'm going to talk about video streaming. There's a lot of slides here. I'm going to go quite fast. If people have questions, Gemma's agreed, it's fine. You can shout out or stop me, or if I'm going too basic, shout as well. Gemma and I were just talking, and Gemma gave a really good use case of video being tricky. So anybody in the South will be used to using RTE player, which is interesting. And Gemma was just saying that on her smart TV, and the word smart TV is a misnomer if ever there was one, it doesn't work, so you have to use it on an iPad. And, you know, RTE, okay, it's a bit distracted at the moment, but it's not a small organization, and you would think they would have the resources to get a video stream, which is their main business, working across all devices. So I'll try and talk a little bit in this talk about why it's tricky. Just to save time for anybody who's desperate to go next door for the refreshments, if you're only worried about getting a video working on a site or on a mobile, you're not a Netflix or an RT player or a iPlayer or so on. You just want a video to play reliably across devices. Very, very simple answer right now, and it changes all the time. But right now, package it in MP4, encode it in H.264 baseline profile, use AAC for audio, and just use basic progressive download streaming and the video tag on web. Exo player on Android and iOS is built-in player, and that'll work for 95% of the cases. So that's just the quick answer. That's the light at the end of the tunnel. Okay, so I'm Mick O'Doherty. I'm a technology consultant, background in telecoms and video and so on. Contact details there if anybody wants to reach out. So again, starting with very basics. Probably everybody knows this, but digital video. Video, first of all, is just a whole lot of pictures moving very, very fast, so a little bit like this slideshow. And digital video is just taking those pictures and representing it at ones and zeros. Nothing too complicated. And then at the other end, taking the ones and zeros, making the picture again. Okay, so each one of those individual frames, if you want, and let's say you've got 25 of them a second, for example, is made up of lots and lots of pixels, depending on the definition, and each of those pixels is defined somehow. So typically red, green, and blue. That's a format that most people are familiar with, and each of those is typically a byte or 2 bytes. It depends on the format. Okay, so that means that videos get very big very quickly. So what we're looking at here is a 4K video at 60 frames per second, and this is just 5 minutes of it. And the reason I've got 3 circled there is because it probably wouldn't be just 3 bytes. You would be using HDR. You'd be using a deeper color depth, which I'll explain in a second. So it'd actually be even larger than this. But you can see very, very quickly we're up to 0.5 gigabyte of storage just for 5 minutes. I'm pausing there because I'm probably mistakenly converted between bits and bytes, but large is the summary of the answer. There's lots of standards coming along, and again, the reason for highlighting these, if you look at the bottom one, moving towards 8K. Now, 8K hasn't had the uptake in the industry they were expecting, but it'll probably get there eventually, and that just means bigger and bigger. Something that's quite interesting, especially if you are going to buy a TV, a smart TV, for example, the color range in the TV actually makes generally a bigger difference to the quality than the bit rate. So everybody goes for 4K or 8K, etc. If you can look at the diagram here, the HDR color range you can see is much, much bigger, so they can display more accurately and more vividly more colors, and that's why you get better quality in TVs with those in it. So that's just a quick aside if you're looking to buy a TV. Okay, because everything's so big and because what we're talking about is streaming, and even if you just want to store it, compression is very important. So video compression basically just takes the frames, takes the video file or the video stream and reduces its size, and then on the other end uncompresses it again so as you can display it in its correct size. Nearly every single video compression scheme works by taking a picture at, say, at one point in time, then going ahead, say 5 frames or 10 frames, seeing what the picture looks like then, and instead of encoding each one individually, the ones in between are encoded with reference to the first one, or in more complex encoding schemes with reference to the first one and the last one. So I'll try and explain that a little bit more, but the point of this diagram is to show that if it's a football match, unless it's the Republic of Ireland playing, you'll have a lot of movement. And so it changes a lot between frames. If it's, I don't know what that bottom window is from, but let's say it's an Inspector Morse and they're in one of their deeply pensive scenes or sequences, you might actually have the same shot with very, very little movement in it, and you can get much, much higher compression because there's very little changing from frame to frame. Okay, so hopefully what this is showing is we started like really, really simple stuff that everybody knows, and it gets complex really quickly. So you begin to see why it's a tricky area. So this is basically saying the same thing again. The iframes are the ones that you essentially encode every single pixel in. The frames between those, you can, if you take, say, the 5th pixel, you say the 5th pixel hasn't changed from the iframe, so we don't need to encode that. We just note that it hasn't changed, and that saves a lot of space. The more sophisticated techniques, as I mentioned, will actually reference forward and backwards. And that is actually important because it means that to decode them, if you want to look at the one of the middle frames there, you have to have the frame that came before it, but also the frame that's going to come after it. So that has an impact on how you stream video. You have to build up a certain amount of it before you can start playing back, before you can start even decoding it. Okay, so the purpose of this slide is really just to say that there are a lot of complex maths in the encoding. It isn't just as simple as taking a pixel and saying it's this amount of green and this amount of blue and so on. There's a lot of complicated cosine-y stuff involved, and I'm not going to talk about it here. The only reason I'm saying it here is because it exists, it's complicated, and it uses a lot of processing power. Okay, and that, by the way, is why it's a really big deal what your device supports. That's why you'll see Apple making a big deal about the particular battery life they have for Netflix. And that's entirely dependent on Netflix encoding it in the codecs that they have built-in hardware for. If it has to fall back to software, it has to do a whole lot of computations on the CPU instead of in hardware, and suddenly your battery life will drop alarmingly. Okay, so packaging. Well, what we talked about so far is encoding the video. To actually get it from one place to another, or even just to store it, you will have video, audio, subtitles normally, subtitles sometimes, and also metadata, information about the video. And metadata becomes increasingly important if you're running a Netflix or a YouTube or so on. These are generally all put into a single container, which is container or file if you want, or stream. And again, you'll be familiar with some of the more common ones like MP4, WebM, AVI, and so on. So if we go back to what I said right at the very beginning, H.264 codec, MP4 container, AAC audio, that's kind of the sweet spot at the moment to make everything work. Now, the devil is in the details, so H.264 has many different profiles, so you want baseline to make it work across as many as possible. Timing is very important, obviously, to keep the audio and the video in sync. It's actually surprisingly common for them not to be in sync. It's just that you normally don't notice because they're not too much out of sync. But it's not unheard of for even, again, major broadcasters to have their audio creep out of sync with the video. Timing is also important if we go back to what we were talking about earlier on about the decoding. So PTS stands for presentation timestamp. That's when you present that frame on the screen. And DTS is decode timestamp. That's when you have to decode it. So the interesting thing here is that if you look at the time when you have to decode, the presentation one, obviously you go 1, 2, 3, 4, 5, 6 for your video because you want it to play in the right order. But the time you have to decode them is different because of the iframes and the frames in between. So hopefully that makes sense. Okay, so now we've got a video, we've encoded it, we know how to package it. So it's still very large. We could just download the entire video to the user and they could watch it. They could then start watching it. But because it's so large, it takes a long time to download and people don't want to wait. So you want to be able to watch it while it's playing. And that's where streaming approaches come in if you want. So the simplest form of streaming is what's called progressive download. And nearly all servers and pretty much every device supports this. And it's really easy to implement if you're just building a website or building an app. You just put the video there. You use the video tag or one of the standard players and it'll automatically progressively download it unless you tell it not to normally. Okay. Now, it's not 100%. You may be unlucky enough to be on a server that doesn't support byte range requests, which is where when it makes a request, it can just ask for this chunk and then this chunk and this chunk. It's on enterprise servers, it's actually, you will sometimes find your server doesn't support that. It's a very easy change and normally it's just for historical reasons, your admin or your IT department won't mind, but just be aware you do need to have byte range request support on the server. Other than that, very, very simple and works reliably across nearly every device. However, the quality isn't great, it doesn't handle different network conditions and different device capabilities very well. It's the same for everything. So a set of streaming technologies were invented, if you want, called adaptive bitrate streaming. And what they do is essentially you take your single video and you create multiple versions of it. Say, I've used 5 here, but most commercial ones are probably using 8 or 9 different versions of the video. And the smallest ones will be very low bit rate and the largest ones will be very large bit rate. They then chunk them up into equal size, not by bits, but by time. So you get, say, a 2-second chunk or a 10-second chunk of every bit rate. And what that means is when you're watching the video, depending on the network conditions and depending on the device type, because if your device can't handle 4K, sending 4K to it is actually not a good thing because the device then has to downscale it. What you'll generally start is a low bit rate because that allows fast startup, and then you'll move up into higher bit rates. And if there's if there's network congestion or if the high bit rate is just proving too high for the network, it'll drop down. So it steps up and down the bit ladder as you go. And again, hopefully that makes sense. You can see this as you stream things. If you start Netflix or start YouTube, you'll often find the resolution isn't great when you start, and then it'll step up. You can also obviously go in and manually override it, and if you do that, you'll sometimes find that at the highest bit rate, it keeps on pausing to buffer because it can't maintain that. Content protection. So this is an area I've worked quite a lot in, the popular field of DRM. And it massively complicates things because all of the debugging and the checking you'd normally be able to do, you can't if everything is encrypted, because you basically can't read it. If you can read it, then the encryption is not working. Now, DRM and security in general is a constant battle, so there's plenty of examples of past cases where DRM gets broken or where there's ways around it, and it's constantly evolving and constantly changing. It is a significant complication if you're running a streaming service, so unless you need to encrypt the content, I really wouldn't. So end-to-end OTT. So now we're at the point we just, as I said, we just choose our favorite codec, container, create a video, encrypt it if we want, and then stream it to playback on any device, okay? So you already know that because of what I said at the beginning, that doesn't really work. And the reason it doesn't work is because there's multiple containers and codec formats. So I'm not going to go through them all, but there's lots of them. There's different devices support different combinations. So what plays on an old Android device won't play on a new Android device or won't play on an Apple device and so on. And different browsers support different combinations, just to make it more complicated again. HLS, for example, which is one of the two mainstream protocols. I should have mentioned HLS and Dash are the two main ABR streaming protocols. HLS is semi-supported in some browsers, always supported in Apple browsers, and not supported at all in other browsers. So, and the same is the case for codecs and containers. And it's a little bit more complex because generally anything can support anything, but you end up having to add software, or it has to use software to do a lot of the work that it would otherwise do in hardware, and suddenly it takes longer. Your fan starts going on the computer and your battery life drops. So these are subtle things, but they're important. Unfortunately, this isn't invisible to you if you're a web or a mobile app developer. You have to know about these things. If you want to make something that works across sites, this is a common site, which is, what's it called? Video for Everybody. If you just Google it, it's generally got the latest view of how you can make something work across as many sites as possible. Now they didn't do what I did at the beginning, which is just pick a single one that'll work 95% of the time. They've kind of gone for that extra 99%, and so you'll see multiple formats of a video. What this means in practice, and encryption makes it more complicated because Google, Microsoft, and Apple all have their own particular encryption, and they're all slightly different, of course. So what does this mean? To serve one movie for streaming properly, so in other words, using ABR and with content encryption, you start off with your one video file, you end up with 2 different encodings, 5 different bit rates, 3 different DRM encryption technologies, 2 different streaming formats, and you end up with 60 copies of your video. And you're probably all expecting me to say this doesn't really happen, and this is just an example of the worst case, but this actually does really happen. And it is a ton of... So we live in a world now where storage is relatively cheap. Oh, I've just discovered I can get out of the lights back here. So storage is relatively cheap, and processing is high, so people don't mind it so much, but it's still, it's still expensive, especially when you've got petabytes of content to deliver. So there is light at the end of the tunnel. Some of the new combined formats and combined multi-DRM allow you get that down to sort of 20 or 40, depending on how you do it. I've still using 5 different bit rates here. Most of the top ones will be using more than that, but it's around that. Unfortunately, the CDN still has to pull through every single different version that goes through, and CDN costs are high. So still not ideal, but that is state of the art today. That's exactly where we're at today. Netflix, YouTube, iPlayer, RTE player, everybody does it this way. So they will have multiple versions of the video and stream it depending on your device and network capabilities. Okay, so what's coming next, and is it getting any simpler? So you can probably guess what the next word is. Nope. It's not going to get any simpler. And it's not, some things may get simpler, but there's lots of interesting things going on, and they're good, interesting things. Like a lot of good, interesting things, the technology that makes this microphone work or this computer work is phenomenally complicated, but it works reliably. It doesn't mean it's not going to work, it just means it is complex. So low latency, the use case that's always given for this, which is a very bad use case, is if you're sitting in your apartment and somebody scores a goal in your World Cup of choice, or a try or a wicket, and your neighbours hear it before you and they cheer and then you become disappointed. That's not actually a latency issue, it's a synchronization issue, which is a completely different and almost unsolvable problem. So a lot of the operators have kind of lost interest in low latency, but not totally. The biggest driver for low latency now is actually betting, because there's serious money. Betting is coming down to sort of, less than a minute. People are placing bets on events that are down to granularity of less than a minute, and so low latency is really, really important for that, and that's probably driving a lot of it. It's horrendously complex. It breaks the segments I talked about earlier, which might have been 2 seconds, come down to, I don't know, a tenth of a second, or maybe say a half a second. There's a lot more metadata that gets sent around. And probably the thing that makes it most complex is none of the devices yet support this. And as rollout for it goes, you'll have some devices support it, some devices that don't support it, and you'll have to add to your complete stack of video formats to support both the new and the old devices. Dynamic ad insertion, this is personalized ads where, you'll see one ad, you'll see another ad, you'll see another ad in the ad break based on what you've been browsing or whatever they decide is the most appropriate thing to sell to you. So the key part of this slide is if you look at the ad break and if you look at the segment sizes, the things with S's in there, they don't align nearly always. So that means that you have to take a segment of your video and actually cut it in half somehow and splice it. And the technical side of that is tricky, and also the continuity. If you splice it just in the middle of an action scene, it can be tricky as well. So ad insertion is complicated. It's definitely here. Personalized video streams is very, very similar to ad insertion in that there's a friend of mine who works for a Dutch company who's, the example he always gives is he's a big Verstappen fan, so things are going well for him at the moment. But he reckons he doesn't have enough time to watch an entire Grand Prix, or maybe enough interest to watch an entire Grand Prix. So what he wants to do is he wants to be able to just say, show me all the overtakes, or show me all the interesting bits involving Verstappen. And then the back end, using some sort of AI stuff, almost certainly will go away, build him up his own personal highlight reel and play that back for him. Okay, now that's brilliant, that's a great service, but as you can imagine, that's quite complicated. Okay, and finally, magic dust buzzword bingo. So, as with everything, we've got to have our magic dust buzzwords. So the current buzzwords of the year are obviously cloud, had a good long run. Blockchain, which I think is just about going out of fashion, and AI ML, which we're probably going to be living with for a while. So cloud, everything I talked about here can run on the cloud, can run on premise. Videos are very, very large, and clouds charge a lot of money for ingress and egress. So it's actually a really big, if you're talking to an RT or a BBC or an ITV, it's a big deal for them where they do their processing and what they have on cloud and not on cloud. Generally, it's not a good idea to have, your store it off cloud, process it on cloud, and then bring it back. That's just too expensive. So you generally tend to do it all in one place. So either all on cloud or all on premise, or else some sort of sensible hybrid of those two. So that's the first thing. A lot of operators now are moving to the cloud. Cloud native is a very, very, very badly abused term, so I won't use that. Cloud's own services. All three major clouds, AWS, Google Cloud, and Azure, had media services 3 years ago, I think. If you probably can't read it, but the note under the Azure one is that it's shutting down next year. Google have already stopped their one, and they're recommending that people use partners on their cloud. Amazon still have their own one. They bought a company called Elemental they've heavily invested in, so they still have their own media services. The logic the others are using, and that Amazon may go to eventually as well, is at the end of the day, they make their money from people running processing on the cloud and storing things on the cloud. So it doesn't really matter whether it's their own or whether it's their partner, so long as people are doing it on their cloud. Blockchain. So blockchain got a huge amount of attention initially, especially in the content security world, where it was seen as maybe some sort of replacement for DRM. That definitely hasn't worked out. But what it is been used for a little bit and probably will continue to be used more for is in a chain of, a chain of trust, or a record of who's touched a particular piece of content, especially in pre-production, where content is, since COVID, a lot of content that's produced is produced around many, many different studios and editing suites and so on. And so it's quite important to have that chain of trust, or chain record of what's happened. And finally, AI ML, and this is where it's not really just buzzword. This is really, really interesting stuff in video. There's many, many applications. So you can create videos using AI now. You can type in text and tell it what you want to create. Give it, it'll take some basic headshots and some basic movements and speech shots from somebody and create an entire video from them, which is quite interesting. There's obviously deep fake video creation, which is AI driven, and the detection of deep fake, which tends to be AI driven as well. Green rooms. So green rooms are expensive. I think everybody's seen a green room, green background, and then they put everything in it. It's actually becoming cheaper to do some of that with AI now, and that's a big, big change to the industry. If you go to any of the trade shows, half of the floor is green rooms, so that's going to be a big change. Video editing, enhancement, upscaling, downscaling as well. Metadata enhancement, really big thing as well, because I think everybody is familiar with how rubbish, especially Amazon Prime's recommendations are. You see things, why on earth are you recommending this to me? It has nothing to do with anything I'm interested in. Those are going to get better and better, and a lot of that requires more and more information about the video. So essentially AI will watch the video and extract keywords and tags to try and make those recommendations better. And context-aware advertising, I'm afraid, is going to come where they're going to target more and more stuff at you that they think you want, generally wrongly. Okay, so I realize that's a bit of a whirlwind tour, but hopefully it's answered some questions and given some pointers to what's coming. Please feel free to reach out either now or after the show. If anybody's any questions, always happy to help. And video is tricky, and I know all you need just to go on to Stack Overflow in the olden days or ChatGPT and see the answers there to see what's going on.
Well, we've probably got time for one question. Does anybody have anything they would like to ask? Put your hand up so I can run to you. Anybody? Yes? Great. Okay, you're a bit far away, but we'll make it work. Okay. Here you go.
I remember when OGG was brought into browsers, and there was a big effort among the browser vendors to standardize the format. Did that just... what happened? Is there a lot of standardization still happening, or is the innovation just getting ahead of it? Are the browsers working together on all of this generally?
Yeah, so it's interesting. So there's a lot of, I recommended H.264. You guys don't have to worry about it, but there's a lot of patents involved in H.264. So the people who make the devices and the people who make the encoders have to worry about that. As you say, things like OGG and some of the VP9 and so on standards, where the idea was to try and work against that, to try and make it completely open. A lot of it was Google driven, and I think there was some resistance to Google driven, Google behind it, because people weren't convinced that it was as open as it maybe was promised to be. There's been a lot of, again, open source standards where patents suddenly appear after everybody's embraced the open source standards. So I think a lot of it is just cautiousness. Most of it's patent related and companies' own interests. There's a lot of people with a lot of energy, effort, and money invested in the existing codecs. Plus, because they have the expertise and the energy, the more proprietary codecs like H.265 now are actually better than some of the open source ones that they were aiming for at the time.
Fantastic. We have run out of time. So as you said, if anybody has any more questions for Mick, you've got your contact details. You want to skip back and everybody can take a picture so they can contact you directly. And then we'll head to Hall 1A for closing remarks. So lastly, just give Mick a massive round of applause and thank you so much.
Thank you. Thank you.